let's get started. I guess there's nothing left but the final project and the final exam. So the key deadline for the project today is to, if you are a member of a team, if you're not a member of a team yet, you need to sign up. There's still something like 80 students that haven't done that. You just won't be able to hand in your project, any of your code, unless you do that. So do that. All right. Any questions or problems about anything before we go any further? Yeah?
How do you do the generate the documentation? I tried to look it up.
Okay. That's actually something I'm going to do early on, so I'll save that till I do it. Yes?
What's the best way for us to work with our partners as far as saving the code? Is there maybe saving online or? Okay, so yeah,
the question comes up. How do you coordinate with your partner on code? So one way to coordinate with your partner on code is just to only work on the assignment when you're physically sitting next to your partner. That may not work for you or for other people. But that's a great way to work because you can sort of serve as a check on this, one of you can check the other isn't making mistakes. And that way there's only one copy of the code. If you find that you have to work separately and occasionally coordinate, then you've got this coding issue. So the standard solution is to use a repository. And the kind of repository that most people use now is a Git repository. So a repository is just a server, or at least a remote Git repository is a server that has, that just maintains not just a copy of your code, but a history of the changes in your code. And it's set up to allow two people to check, to get the code, modify it, and put it back in the repository in such a way that it will either automatically figure out how to combine the changes or have you intervene and do that. The problem with Git's a great thing to learn, but it might be a bit much to learn just for this assignment. So, if you're not going to go that route, probably you're going to end up just emailing the code back and forth, or emailing the project back and forth, or something.
Using a Discord with my partner.
What's that?
There's a service called Discord, and me and my partner are just copy and pasting our changes to codes into chat.
Okay. So yeah, so you can find ways to collaborate, but the communication is the key. Make sure each of you knows what the other is doing. Hopefully you touch different parts of the code. Any other questions? Okay, so as I mentioned, what I want to do today is just talk about the final project, but of course I always have ulterior motives, and my motive today, in addition to talking about the project, is to just consider the problem of how do you describe a relatively complicated program to someone. It's one thing to describe how a method operates, but how do you, if you're trying to describe the Asteroids program to someone, where do you start? What do you do? So who has some ideas? When you got to describe a program to someone, what do you do? Yeah?
You could describe the different parts that make up the program.
Well, he said describe the different parts that make up the program, and by part, I assume you mean like the classes and the interfaces. Yeah?
Talk about the goal.
Okay, so there, instead of here, he's talking about the implementation, you're talking about describing what it is a program's supposed to do. Yeah? Yeah?
That plays into an audience. If I'm making the Asteroids game and I'm trying to talk to the player, I just need to explain to them how they play the game, what
right.
the controls are, and what to do. If I'm talking to someone who I'm, the person helping me work on the project to make the game, they're going to need to understand more than just how to play it.
Okay, so you certainly got to take the audience into account. Yeah?
Explain all the moving parts, but more importantly, explain where they connect to each other and how they interact.
Okay, so when you describe the parts, you got to describe how they fit together, how they interact with each other. Now, when I describe something that's fairly complicated, I tend to draw pictures. So if you're sitting at my desk, I'll take a piece of paper and I'll start drawing pictures, or diagrams, or I draw it on a whiteboard or something. So I'm going to start describing the version of the Asteroids program that I gave you by drawing a picture. So let me Stefan, are you in control here?
Yes.
Okay. Let me bring up Eclipse. Take down the lights. So that diagram is illegible. I can blow it up in a minute. But each rectangle, see there are a bunch of rectangles in there. Each rectangle is one of the classes or interfaces from the Asteroids program. And the lines between them, if essentially there's a line from one to another if one of the, an object of a class would contain a reference to an object of the other class. So the lines have to do with instance variables. So this is called a class diagram. In particular, it's a UML class diagram. So UML stands for Unified Modeling Language. And UML provides a bunch of standardized ways of drawing diagrams to describe programs. And class diagram is one of the most commonly used ones. I'm not particularly interested in any of us becoming UML experts. I just wanted to show you that there's a different way, there's a way of sort of graphically looking at how a program is structured. So what I had to do to generate this diagram is I had to, first of all, add a plug-in to Eclipse. The program I'm using is called Object Aid. And then, I just added a class diagram to my project, and I had to drag all the classes I wanted to be in the diagram into the picture. Then I had to spend a long time rearranging things so that the lines didn't cross. It didn't provide any help doing that. So you got the big picture, that these are classes and interfaces. So let's, I'm gonna blow it up a little bit so you can see what's in it. Okay, so that's blown up quite a bit. So we'll just start up in this corner here. Is that visible in the back?
Yeah.
Okay, I'll do one more. Okay.
Would we be able to get this list?
Yeah, this will be in the project, and I'll post it after class, but you'll need the plug-in to actually look at it. So I'll include information I gave the
What
plug-in.
if we've already been working on the project?
What's that?
What if we already have the project?
It's not a problem. You can add the plug-in later. Okay, so look in the upper left-hand corner. We've got Asteroids, and it says at the very top that it's a class, a Java class. And it even says what package it's in. And then it lists the, you see the constructor and the two methods. Now, you see that the methods are annotated at the beginning there, with like asteroids, there's a little green circle and a C. What do you suppose that means? It's trying to summarize a lot about the class. What would you guess the C means? Yeah? Constructor. And what about the little green light? Yep. No, not that it's a method. In fact, it's a constructor. So, what other property do things have besides names and types? Yeah? Yeah, it has nothing to do with inheritance. Public, yeah. So green things are public, and I'm not certain, but I believe that must mean private. We can see later. I'm not really certain. That S means static. So anyway, you can see it'll show you what methods are in the class. Now, if you're curious about a particular method, I come here to main here and double click. You can double click very well, and it will bring up the main method. So it provides a way to navigate into the code and see what's going on. Okay, so that's Asteroids. Now, this Asteroids class doesn't have any instance variables, and so it doesn't show any connections between it and the other classes. Here's the constants class. So that's a class. I guess I can describe the classes as I go along, because again, I'm trying to introduce the final project to you. When I wrote the full game, I ended up with a bunch of constants that I used. Everything from how many pixels over, how many pixels down to display the label, a legend, what's the maximum speed something can go, how much does the ship accelerate every time you push a button once. And that's all defined in here. including, there are lots of constants in this file here, in this class, that aren't defined, that aren't used anywhere in the program. They were used in my full program, they're not used in the stripped down program. So if you find yourself wondering, where should I put something, or how big should this be, or how fast should this be, you might find the answer by looking through this class file to see what there is. For example, bullet duration. My game has no bullets. What do you suppose bullet duration is? Yeah?
The amount of time the bullet is allowed to be in screen for visitors.
Okay, so when you fire a bullet, it goes for a while, and after some amount of time, it disappears, it expires. So that's just a constant. If we could go look and see what it is. It's 1,000. So it's 1,000 milliseconds. So after 1,000 milliseconds, after 1 second, the bullet goes away. So just to emphasize, that's a good place to go to look for just constants that you can use. Like this one here. Initial beat, fastest beat. That has to do with, when you're playing the game, there's this background sound, boom, 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 and it gradually gets faster. So initial beat is how frequently it beats when the level starts, and final fastest beat is how fast it gets in the maximum. Yeah.
So are constants like that available in any class in the package, or like any class ever?
Okay, these are all declared public, so they're accessible anywhere. Now, let me show you a neat trick that I haven't talked about. Normally, if you wanted to use, say, size here, you would have to say, from another class, you would have to import the class, constants, and then in the code you would say constants.size, constants.title, constants.start label, and so on. And it gets kind of a pain to put that constants dot in front of all your constants. So there's a way to get away from, there's a way to not have to do that. So I'm just going to have to pick a class other than okay, here is participant, and let's look. Okay, look at this import right here. That's called a static import. So if you say import static, and then you give the name of a class, dot star, that just says make all these constants available in this file without having to put constants dot in front of it. So we can probably find a place, I don't know if we can find a place where it's used. So if I comment this out, presumably it'll cause some errors. Yeah. So right down here, you see speed limit, right, since I took out the static import. But I don't have to say constants.speed limit. I just have to say speed limit because of that static import. Okay? Yeah, so please ask questions as we go along here. Right now I'm giving the introduction to how the program is structured. So this constants class, very useful. This random number generator is useful as well. Instead of, there are a lot of things that you decide at random. Rather than create a new random number generator every time you got to make a decision, just use the one defined in constants. You can just invoke methods on it. Yeah?
So like that bullet duration thing, as far as like, that's what establishes how far the bullet's allowed to go. It isn't like it can only go this so far in a distance. It's only allowed to be here this amount of time.
Yeah, bullet duration, it doesn't have anything to do with distance. It has something to do with time. Then there's bullet speed. Bullet speed is the speed of a bullet. So I can't promise that every constant you need is in there. I tried to put it in there, but I overlook things sometimes. Okay, so constants is sort of sitting by itself there. All right, let's look at the asteroid class right here. What do you suppose it's telling us there about the asteroid class? The asteroid class, by the way, represents each asteroid is an asteroid object. Yeah.
Well, it extends participants. The asteroids are participants.
Okay, well, this, in particular, what about this little arrow right here? Notice the arrowhead. This arrowhead means something. There's a different kind of arrowhead right there. Right, this just says that the asteroid class implements the ship destroyer interface. And then if we scroll here, you'll see that this is the same sort of arrow. In this case, it means that the asteroid class extends the participant class. So participant's a class that's extended here. Okay. And you'll see the same thing over here. So this asteroid implements that interface, extends this participant class. And I don't know why it's doing that, but it did. The ship class, again, extends participant. This arrow points up to the participant class. And it implements the asteroid destroyer interface. So those are the only two things that, that move around on the screen currently in the version I gave you. They both implement participant, and so that seems like an important thing right here. A participant seems very important. So let's focus on that. So participant is actually an abstract class. What is the intention? What's the point of the participant class? What does it provide? So it's intended to be extended. Every time you create a new actor in the game, you need to extend the participant class. So what are you getting? Yeah?
Like represents like all the little objects that you're interacting with in the game.
Okay, so it gives you the methods, the behavior that all participants, whether they're ships, bullets, asteroids, debris, whatever, what they all have in common. Okay? Now, there are things they don't have in common. They look very different. Right? An asteroid doesn't look like a ship. So the specific way you draw something, a participant, is not part of the participant class. That's what you have to provide when you extend the class. But look at the instance variables right here. So this block right here holds the instance variables. So what properties does a participant have? Read as well as I can, yeah.
It has things that represent movements. It's representation on the screen.
Okay, so a participant has a speed. Okay, and so it has a speed in the x direction and a speed in the y direction. Just you can think of that as a vector. So it's moving in space. What is rotation, do you reckon? Yeah, let me get.
Is it its orientation?
Right, it's the orientation of the. It's not. Yeah, it's the way it's facing. So think of a ship. A ship could be facing straight up, or you could rotate it 90 degrees, and now it's facing to the right. Rotate it 90 more degrees, and it's facing down. So it's the way the drawing is turned. So when you take a ship and it's not moving, and you just rotate it, what you're changing is its rotation. Okay? X and Y is just where it is on the screen. X and Y coordinate. Coordinates, by the way, are measured in Java from the upper left. So X goes across, Y comes down. Border is the shape, the outline of the object, the drawing of the object. Shape being a class built into the Java library somewhere. And then expired, it just turns out that sometimes it's useful to mark a participant as expired, i.e. destroyed, so that to avoid confusion inside the game. So that's what that is used for. But then you can see what the methods are like. We can expire a participant. We can test if it's expired. We can set its velocity. We can set its direction. We can set its speed. We can get direction, and so on. So all this, what this participant class gives us is it can deal with the motion and the appearance of any participant, which means there's a lot of trig you don't have to do. There's trig involved in calculating if it's here right now, where is it going to be the next time it's redisplayed. That's all done for you. You don't have to re-implement that yourself every time you create a new participant. You just have to give the details that are specific to the participant. Now, what details are specific to a participant?
Shape.
Okay? The exact shape is specific, and it may confuse you why there is a shape right here. I'll explain that in a second. Okay, what else? Yeah?
What interface it implements, the actions it performs.
Well, Yeah, I mean, that's an aspect of it, but what things are different from participant to participant? What capabilities?
Who destroys what?
Okay, so who destroys what? Or in other words, what happens when two things collide? When something collides with a ship, say, what's supposed to happen? Versus what happens when something collides with an asteroid, and that's different. If a ship is hit by an asteroid, the asteroid splits and the ship is destroyed. If two asteroids collide, nothing happens. So let me scroll down a little bit more, and you'll see these two abstract methods right here. Get outline and collided with. So those are methods that you have to override when you implement another participant. So get outline is a method that returns the shape, how to draw the participant. So you're overriding this, and this method is what is used to find out what's stored, to determine what's stored in this instance variable right here. And then collided with is a method that, again, is abstract, and its job is to decide what to do. You're telling, when this method is called, you're telling a participant that it just collided with some other participant, and that method decides what to do about it. Okay? So if we look down here at Asteroid, you'll see that it implements collided with and get outline. Plus it has some other methods. And ship also implements those two methods, but it has some other public methods that are needed as well. Why does the ship have a turn right method, or a turn left method, or an accelerate method, or a method to get the x and y coordinates of the nose of the ship? Why does a ship need to have those? Yeah.
You're going to be controlling that.
Right. The ship is, the thing you control. And so the user interface, the class that, figures out, is watching the keyboard and deciding what to do, if you hit the right key, it needs to turn the ship right, or turn the ship left. Or it needs to fire a bullet, and to fire a bullet, the bullet's fired from the nose of the ship, so it needs to know where the nose of the ship is. So it needs to be able to find that stuff out. So that's why the ship is more complicated than the asteroid. The asteroid is pretty simple by comparison, because it's nothing the user controls. It's started and it just moves until it collides with something. Now, while I'm on the topic of collisions, here's a fine point you need to know. Your shapes all need to be closed loops. Okay? They have to have a positive area, because the code that I provide that detects collisions does it by intersecting two shapes. And if you're drawing something that's not a closed curve, it doesn't have an area, and if it doesn't have an area, no collision will be detected. The most commonplace, as it turns out, is people will draw a bullet as a point, a single point. And also, that makes it kind of hard to see, but also it won't intersect, it'll never collide with anything. No collision will be detected with a point. So you can draw your bullet as a little circle or a little square, it amounts to the same thing, just as long as it has some area to it. Okay, so let's back out a little bit now. So we've talked about the participant class, which provides all sorts of functionality for you that you don't have to duplicate. And we see how you create new participants by extending the class. So asteroid, we extend participant. Ship, we extend participant. You want to do the same for bullet. Anything that needs to be in the game, moving around, interacting, needs to be a participant. Yeah?
So you mentioned how the bullets have a problem with dogs. What if there's a small line?
Small line doesn't have an area either.
Okay.
And in fact, I noticed, I was playing the game and I noticed that, okay, so the ship is like a letter A. And the asteroid came along and just clipped the leg of the A, and it didn't destroy the ship. I think because that part of the ship doesn't have any area. So.
And it has to contain itself. You can't line, all connected, and then it almost connects, but there's a small little.
Yeah, no gap. You got to draw it as a closed polygon or a closed circle or something. Okay. participant countdown timer. Yeah.
How would we get like the number of a specific participant?
The number.
Like how many there are. There is the get participant method, but it doesn't like pass a parameter of the specific like object.
Where is the get participant method?
There's in the participant class.
Get participant. I don't see one here.
So one of the participants.
There's get participants. Let me talk about this class first before we look at it. Yeah, there's not a method like that in participant class. Okay, participant countdown timer. Okay, that's a useful class. The way it works is you create a participant countdown timer and you give the constructor a participant and a time. Then when the time is passed, when that amount of time is passed, the action perform method is invoked on the participant. So you'll see that right here.
Nope.
Nope.
Yes, okay, well, I'm sorry, I was jumping ahead.
Oh, okay.
The action performance is provoked on the countdown, on the participant countdown timer, which runs.
Okay, let's look right here at the method. Okay, so I got it a little bit wrong. So the idea is you give the constructor a participant and a time in milliseconds. When that amount of time is passed, the participant's countdown complete method is called. Okay? So if you're a participant, let's go back to the diagram. So participants have a countdown complete method. It's right here. Okay? So why would you want to use a participant countdown timer? Go ahead.
You have that bullet like duration constant. So
Okay. So a handy place to use it, the bullet flies off, and after a second, it needs to go away.
Also for the spaceship.
So what you can do is when you create the bullet, you can create a participant countdown timer at the same time, and when the second has gone away, then the countdown complete method is called on the bullet. You can get rid of the bullet. Okay. How do you get rid of the bullet? One way to do it is to expire it. You can expire something that basically eventually removed from the game. Okay, so that's participant. Asteroid. Now here's a class, participant state. Now there are classes that you are going to need to modify, and there are classes that you probably shouldn't touch. This is the one you probably shouldn't touch. If you find yourself feeling like you need to muck around in participant state, think again. This is the one that keeps track of the participants and moves them every time the clock ticks and checks for collisions and that sort of thing. So you shouldn't need to bother that class right there.
How did you count bullets? Because I counted bullets in here. Did you count bullets somewhere else?
No. Let's see. There's count asteroids.
Right, I copied that to count the bullets.
Yeah, I guess okay, so Stefan said he added a method to count asteroids.
Bullets.
Bullets, yeah. Another way you can do it is, it provides this method called get participants. I probably should have done it that way instead. Get participants will return you an iterator over all the participants, and you can write a for each loop that consumes the iterator. So you could add something you could add code to count the bullets without having to modify participant state. If I do this again, I'll take that count asteroids out and put it somewhere else. So yeah, adding methods, probably not a bad, that's okay, but modifying the class by modifying the methods is kind of scary. Okay, so
Don't do it.
we've seen all this stuff. let's look at what's down here at the bottom. So we have three classes, the controller, the screen, and the display. Okay? So what do you suppose the controller does? Yep?
Allows you to move the ship around and do other things.
Okay, so he says it allows you to move the ship around and other things. The controller is the thing that's looking at the user input and figuring out what to do. It's looking at, it's controlling the interactions in the game. So you'll need to modify the controller extensively as you make the game more and more complicated. Then there's the display and the screen. What do you suppose the difference between the display and the screen? Yeah? Let me get you.
The screen is what everything's being put on, the display is controlling what's being put on the screen.
Okay, so it's sort of the difference between, think about the Connect 4 game. You had the whole game, but then you had the central portion where all the action was taking place. So one of these, and I can't remember which it is the whole thing, and one is just where the interactions are taking place. Let's go see. See what display is. So a display is a J-frame, so that's the entire game. And the screen is a J-panel. So it's contained, the display is contained within the screen. So there's not a whole lot of difference between them. All right, so there's a high-level tour of all the classes, all the interfaces. So I can spend some time talking about them in more detail, but I'll see if there are any high-level questions of how things fit together before I do that. Yeah?
So when you're coming up with a program, let's say from scratch, and you have an idea of what you want, would you start with UML or would you start just with a scratch paper?
Yeah, that's a good question. So I teach 3500, and I'll have maybe 3 representatives from industry, people working in industry, usually alumni, come back and talk about their experience. And I always ask them, do you use UML? And the answer is always no. So I think UML is useful for the way I used it right here, to take an existing program and make a picture I can show you. Beyond that, I don't have any use for it. I mean, some people claim they write programs by first making the UML and then fleshing it out into code, but that seems kind of tedious to me. It's great for generating pictures to plan. Yeah?
This is probably too open-ended, but like, for example, when I was doing the lights out game, I was just gonna I just copied a huge chunk of your code and I just started really fixing things, so to speak.
Mm-hmm.
But when you're doing something of this scale, to me it's so huge, right? But what is your strategy for okay, well, this needs all of this and this needs all of this, and
Okay, so it's a little hard to describe the process that I use. And so when I first wrote Asteroids, I wasn't writing the version I gave you, I was writing the gold version, so it has even more classes. I always start simple. I usually don't go into it with the idea that, I need this class and these classes and these interfaces and this is how they're going to fit together. I say, okay, I need a screen with a legend on it. I need the background to be black or something. So I would just write a simple program that sort of looks roughly like what I need. And I will gradually add capabilities to it. And when I notice that things are getting too complicated, that's when I refactor. That's when I say, I really could use a participant class, I would realize. Maybe I'd start by writing a ship class with a bunch of stuff in it. Then I say, and then I can fly my ship around. Then I say, I need an asteroids class. Well, I don't want to copy all this stuff from the ship class and the asteroids class. So at that point, I would create the participant class and take most of the code out of the ship. It's just a process of discovery. When things get sufficiently complicated, I try to find a way to simplify, and that just takes practice and experience. Yep.
So I wanted to add to that too. That's kind of when you're starting from scratch. you'll find a lot of repetitive code, and you'll find, okay, well, I can kind of simplify this by turning it into its own class. However, when you're kind of working as you get more and more into Java, more into other languages, you'll be using a lot of other people's code, and a lot of other people's code you will be inheriting from it. You will be extending their classes and using that as well. So you will get a lot of experience with this object-oriented programming just by advancing your career in this. So yeah, it's not just so much as starting from scratch where you find other classes, but also using other people's code. You will be using or inheriting from those classes as well.
And I'll add to that. Let's say you're working on asteroids, and let's say you're really stubborn and you say, I'm not going to look at Joe's code. I'm just going to write my extensions. That's similar to saying, I don't care about the Java library. I'm just going to write code. And, you need to, just like you need to study the Java library in order to make use of what it contains, you need to study my code, my program, in order to make use of what it provides. Otherwise, you'll end up duplicating what I did. Okay? All right, let's take a quick break, and then we'll dive into the code, and I'll show you a few more things. Okay, now, I was thinking, when we're taking a break, what I have in mind the very first thing you should do when you start working on the program, and I don't know, I could ask, and I bet no one would guess. I'll give you two guesses. What do you think I'm going to say is the first thing you should do? Yeah?
Create documentation.
Well, yeah, that's true. Create the documentation. Yeah. All right. What's the second thing you should do?
Familiarize yourself with your code.
Familiarize yourselves with the code. That's good too. So what's the third thing you should do? Yeah?
You write it on paper.
People have different approaches to whether they sketch on paper or not. Yeah?
Unit tests.
Well, this game would be really hard to do unit tests for because it's hard to automate. Yeah?
First, you have to play the game to see what's going on.
You've got to play the game. And in fact, we got a post today on the forum. I don't know if the student is here, but he said he couldn't get to level 2, so he didn't know what the alien ship looked like. So it occurred to me that I would recommend that you go in and give yourself infinite lives. Right? You got the game. It doesn't. It stops after you're killed some number of times. Initially, it's just 1. Make it 100. Make it 1,000. If you do that, you can definitely get through. You can make your ship immortal. Right? Make it so that it's easy to play the game and get to the places you need to see.
When I was coding, when I did my missiles, it took a long time to do it. I just had I gave myself like 1,000 missiles. Just as many as you need, and then you can just shoot them forever to see how they work, to make sure they're working, so you don't have to keep starting. So I gave myself like 100 lives,
And they don't have to be good missiles.
So what?
If you get a chance, look at Stefan's game. He's added a lot of bells and whistles to it. Okay, so let's dive into a little bit here. So let's start by looking at the controller class, because that's sort of where the action is. So you notice the controller class is a key listener and an action listener. So it's listening to various events that are happening. And it keeps track of all the participants in the form of a participant state. And it keeps track of the one and only ship. And then it uses a refresh timer. Now, a refresh timer, this timer class is part of Java. Let's see what it is. It's javax.swing.timer, so it's part of swing. And that's the heartbeat. That's the heartbeat of the game. Yeah?
I know, this might be a dumb question, but what's the difference between a key listener and an action listener?
What's the difference between a key listener and an action listener? Well, a key listener is an object that is notified when things happen on the keyboard. An action listener is notified when, it depends on, like when a button is clicked.
Oh, okay.
I'm not sure exactly why that action listener is there.
Yeah,
Timer.
I was wondering about that. Why
The timer. The timer calls action performed.
And the start button.
And the start.
And the start button.
Okay, that makes sense.
Yeah. So what I was saying is refresh timer is the heartbeat of the game. So if we go look at where it's created, you know, right up at the beginning, you create it, and every this many milliseconds, it's going to call the action perform method on the controller object. And that number itself looks like it's 33. So every 33 milliseconds, which is roughly like 33 times a second or something, this thing is called. So what if instead of frame interval you did 10 times frame interval? How would that change the game?
It'll be very jittery.
Well, not just jittery. A lot of things happen once per frame. So, well, let's see. I'm not sure exactly what it would be.
That would be one update per second.
So it's only being updated. It's not being updated nearly as often. So let's see. Okay, so you see it's not moving smoothly.
Happens every 330 milliseconds, which is a third of a second.
Yeah.
So you're getting a movement every third of a second instead of 30 times a second.
And you can see that it's turning a bunch in between each frame. So anyway, when I talk about the heartbeat of the game, that's what I mean, is this interval right here. Now, this also causes confusion, is transition time. So sometimes, let's say a level ends. You've killed all the asteroids. It doesn't immediately switch. The game doesn't immediately switch you to the next level. It waits maybe a second or 2 seconds or something before it makes that switch. And the way this is designed to work is transition time contains the time at which the next transition could occur. So initially, transition time is infinite, essentially. You'll see code down below that sets it to something smaller, and then when we reach that point, that's when a transition happens. So it's when the next significant change in the gameplay happens, is at the next transition time.
Like switching levels and stuff?
Like switching levels or spawning the ship again if it's been destroyed, those sorts of things. So anyway, the controller constructor just sets everything up, sets a timer into motion, starts the timer, and brings up the splash screen. There's a method that gets the ship. There's a method that draws the splash screen. That's just what you see at the beginning. There's a method that displays the final screen. There's one that places the ship into the middle of the screen. This places the one asteroid. This clears the screen. This creates the initial screen on the initial level. Okay. Let's look at this method right here. So say the ship notices it's been destroyed, so it tells the controller ship's been destroyed. So first thing we do is we store null, so we get rid of the ship. That's where the legend is displayed, ouch, when the ship is destroyed in the initial game. We decrement the number of lives, and now we schedule a transition for the future. So we schedule a transition, and that just sets that interval variable so that eventually we'll make the transition. Asteroid destroyed does the same thing. If all the asteroids are gone, schedule a transition for the future. To schedule a transition, you take the current time in milliseconds and you add the amount of time. Okay, and then this is the method that really controls what's going on. So the action event timer can be called for 2 reasons initially. Either the start button has been clicked or the timer has gone off. And we tell which by looking at the source. So e.getSource up there is either going to be a J button or it's going to be the refresh timer. So whichever called that, whichever triggered this call to action performed. If start was pressed, we set up the initial conditions. If the refresh timer has gone off, perform transition checks to see if it's time to change to a new level or whatever. This moves all the participants. So the participants are in some position. Every time the the timer goes off, they're moved slightly, depending on their velocity and their current positions. And then we refresh the screen. So if we comment this out while they happen, yep.
You wouldn't see them move, but
Yeah.
their text would still be.
Yeah, nothing, you wouldn't see any motion. So that's what that refresh redisplays all the participants, wipes the screen clear and redisplays them. Okay, and we keep mentioning transition time. This line of code says if the transition time has been passed, if the current time in milliseconds is larger than the transition time, that means that it's time to do something. And so we reset it, we clear the transition time by making it effectively infinite. And then, in this case, if all the lives are less than, if there are no lives left, we go to the final screen. Now, what are some other kinds of transitions you might make in here, in the full game? What would you have to do? I think we've mentioned them already. Yeah?
If you need to go to the next level.
Okay, maybe it's time to go to the next level. How would you tell if it's time to go to the next level?
You do it several ways, however many asteroids you...
Okay, so you might say, okay, if it's time to make a transition and there are no more asteroids, then we go to the next level. Or if there are some asteroids left, but the ship has been destroyed, then we spawn, and there are some lives left, then we spawn a new ship. Or, as we see, if there are no lives left in the game, then the game is over. We do that. So these big transitions, and it's just there so that you don't, it'd be kind of disorienting if you destroyed the last asteroid in that instant, you're on the next level. So this just builds a delay in. Okay? What's going on here? Yeah?
The right arrow is pressed, the ship will turn right.
Okay. So when the right arrow is pressed and the ship exists, then it's turned right by some increment. So what happens, at least what's supposed to happen, I've been reading posts that things aren't happening right on Macs, but at least some Macs. What happens if you hold down the right arrow key? It just starts to spin because your keyboard essentially simulates the rapid typing of that key. It starts auto-repeating after a delay. And therein is the problem. So let me fire the game up again. And I'm going to hold down the right arrow key. And what did you notice? That's going to get destroyed here. Let's try it again. So hold down the key. Okay, press it and continue to hold. What's bad about that?
It doesn't go in the direction.
Well, no, it's not going to go. The direction which it heads is not the same as the direction it's pointing. Yeah?
There's that little delay when you...
Right, there's that little delay. When I first push the key, it turns, and then there's a delay before my keyboard starts repeating. And after that, it moves smoothly. Same thing with firing bullets. If you try to fire the bullets, it can be you push down the fire key, and one bullet's fired, and then there's a delay, and then a bunch more are fired. That's what I want you to change. That's bad. I remember when I first created this, I handed the game to my son and said, play it and tell me what you think. The first thing he told me was,
this sucks.
Yeah, controls were crap. Because he wanted to hold down the key, and there was this initial turn and then the delay. I want you to push down the key, and I want it to turn smoothly. Okay? So people always ask how to do that. Here's the problem. Well, the fundamental problem is you're turning right each time the key press registers, but you've got no control over that. Right? The first press happens, and then there's a delay. You can't do anything about the delay. Solution is you can't, instead of thinking I will turn when the key is pressed, think in terms of I will turn while the key is pressed. If you want to do something smoothly in the game, do anything whatsoever smoothly. What makes the asteroids fly smoothly? And what makes the ship fly smoothly and the bullets fly smoothly? What controls that smoothness? What makes things happen at regular intervals? Yeah.
Does it use like a while loop?
Well, you don't need to use a while loop here. I'm just saying in the game itself. Why does the asteroid fly smoothly instead of jittery? Yeah. Right, it's the frame interval. It's the heartbeat. It's because we move it a little bit each time the heart beats. So think in terms, what you want to do is tie the rotation to the heartbeat. Rotate a little bit each time the heart beats. Okay? So the idea is you've got to notice whether or not the key is down. But if it is down, you don't rotate just because the key just went down. You rotate while the key is down. So you need to put the rotation key. The rotation needs to be tied, and the firing needs to be tied to the heartbeat, not to a key press event. Okay. Now, I've had students in the past read that comment right there. These events are ignored. These events are ignored. And they conclude that they're not allowed to modify those methods. No, this is just documentation saying that the point of this method is to ignore when the key is released. You're going to have to notice when the key is released. Why is it important to know that the key has been released? Yeah?
For turning.
Right. If you're supposed to turn while the key is pressed, you've got to stop turning when the key is released. So you've got to notice both when the key goes down and when the key comes up. That doesn't mean that you rotate when the key goes down. Right? You just notice the key has been pressed, and later you notice it's been released. Yeah? What does what? It's just, if it's pressed and released, it's been typed. So when I press a key, I get a key press event, and then when I release it, I get both a key release and a key typed event. Yeah?
So perhaps a good way to deal with this is to have some sort of variable that changes.
Right. An instance variable that knows whether the right arrow key is down at the moment is an important part of the solution. Okay, so that's the controller. Let's say you get to the point where you've got to make a alien ship appear. Where would that code go? Where would the code go that decides, let's send an alien ship? Yeah?
That'd be a new class, or?
Well, you'd need an alien ship class, sure. That would extend participant.
It would be like a countdown, right? Because after a certain amount of time, the whole ship appears.
Yeah, but I think the idea is you'd have to soup up the controller. The controller has to say, okay, are we on the right level, first of all, for an alien ship? And second of all, then it has to pick a random amount of time at which to start the ship flying. So that's sort of the controller gets the ship started. Now, when the alien ship flies, it can, every second, it changes direction. And it can only go in 3 directions. It can keep going straight. It can turn up by a radian. Is that right? 1 radian?
Yeah.
Or turn down by 1 radian. So it follows sort of a zigzag path. How would you get the ship to turn every second?
Every second, 12 radio.
Yeah, but how would you notice a second has passed? Right, you'd start a countdown timer on the alien ship. And when it's notified a second has passed, it can turn itself. Okay? And you need a random number generator to decide which way to turn. Yeah?
So I wanted to add really quickly the difference between key release and key type. Key type only occurs when an actual Unicode character is sent to the...
Oh, okay. So some keys, like the control key, would never register a typed event. Yeah. Good. Okay, so you only get the key typed when it's an actual character. Yeah?
I'm still not tracking why, like, for example, mouse press, you don't need to worry about mouse release, but for key press, you have to worry about key release.
Okay, let's do it this way. I need a volunteer to stand up. Okay, go ahead. So you're my key. So here's the deal. When he sits down, I'm going to start turning. And when he stands up, I'm going to stop. Okay, so you're controlling me. So, okay, I'm going to start turning. You got to cooperate. I stop. Now, what did I have to notice? I had to know that he had. I had to notice that he had sat down, and that's when I started turning. And then I had to notice when he had stood up, so I could stop.
Okay, well, I click it down, and I lift it up. I mean, it's just different implementation. Like this guy coded mouse press to perform that way, but this guy, like key press, is like this.
No, I'm telling you, when the right arrow key is pressed, turning starts, and it keeps going until the key is released.
You know when you're typing a Word document and you hold down on it takes a couple of seconds before
That's true. That's true. Mouse
Okay, what I'm telling you is the decision to turn can't be based on the fact that the key has been pressed.
I get it.
While the key is down, you start turning, but you time the turning to the heartbeat. And then that stops when the key is released. So you have to notice both transitions. One starts the turning going, the other stops it. Yep.
And you can't make it just based on release, because then it's like you hold down and it doesn't do anything until you release it.
Say that again.
If you have to implement both press and release,
Okay.
because if you only did press, it's only when it's pressed, and then you only did release, it would do nothing until you release the button.
Got to repeat, can't hear.
I would have a hard time repeating it. I'll just leave it at that. So, bottom line is controller class is crucial. You're going to make a tremendous number of changes to the controller class. All right, another thing I want to point out, let's look at the ship class. So the constructor, what the constructor does is it draws the outline of the ship for future use. And I'm doing that because in my little boiled down game, I want the ship to just automatically start in 2 seconds. You, of course, take that out. But where I'm headed for is this. Okay, so a ship implements this interface called Asteroid Destroyer. So let's go look at that interface.
It's really complicated.
So what do you notice about the Asteroid Destroyer class? Interface, I should say. What's unusual about it? Yeah?
It does nothing.
It has no methods. Okay? And you might ask, what good is an interface if it provides no methods? It makes it easy to implement. So I can take any class I want and stick implements Asteroid Destroyer on it. I don't have to add any methods. That's all it takes to implement it. So what can be the only reason? Yeah?
It's just like a marker saying it's this type of thing.
Okay. So in fact, it's called, this technique is called a marker interface. An empty interface is often called a marker interface. It just becomes a property. And a class either implements Asteroid Destroyer or it doesn't. And I just use that so that down here there's a method, okay, collided with it. So whenever anything collides with the ship, this method is called, and we are past the object P that collided. And look what I'm doing. I'm checking to see if that object is a ship destroyer. If it implements the ship destroyer interface, then we destroy the ship. So it just provides basically the marker interface just lets you do this instance of test to find out if an object is of interest. So if I go to the Asteroids class, suppose that's the wrong one, that's the Asteroids class, I need Asteroid. See, it's a ship destroyer. What if I comment that out? That's all I'm changing about the game, is I'm making it so the participant is no longer a ship destroyer. The asteroid is no longer a ship destroyer. So what's going to happen? it's not going to got so little control over the game. Anyway, if I could fly it.
Turn left.
There we go. So it took out the asteroid, but it didn't take out the ship. Okay? That's all. I don't have to change anything. Now, what if I made an asteroid be an asteroid destroyer? Then when asteroids collided, then they would, it depends on my code, but asteroids would destroy each other. Okay? So it's just a really simple technique, but it's common enough. There's some marker interfaces in the Java library that are used for the same reason. Okay? So what other questions could I answer other than exactly how do I do this? Yeah?
So all the interfaces that we need are there. There isn't anything that just needs to be added to it as far as classifying participants.
Well, no. Let's think. So we got these marker classes. He's asking, might we need to add another marker class? I'm sorry, marker interface. Okay, so what do you think?
I think it depends on what functionality you want the game to have.
Okay, well, one thing I want is for a bullet to be able to destroy a ship. So what's the easiest way to make it so a bullet will destroy a ship? Actually, I don't want a bullet to destroy a ship. All right? I don't know if it's possible for a ship to get in the way of its own bullets, but I'd like to be immune from that. So I won't make the bullet be a ship destroyer. But it probably ought to be an asteroid destroyer. What if you want your alien ship to be destroyed when it hits a... I'll tell you something often happens, is people will make the bullet, create a bullet participant, and make it be an asteroid destroyer. And then they fire the bullet, it destroys the asteroid, but the bullet keeps going. Why didn't the bullet disappear when it destroyed the asteroid?
Because the asteroid wasn't a bullet destroyer.
Right. Because the asteroid wasn't a bullet destroyer. So make the asteroid into a bullet explorer. Right? Bullet destroyer. And then you can code. Again, you have to write the method. In your bullet class, you'll have to have a method that destroys a bullet when it hits a bullet destroyer. So no, all the classes you need aren't there. In particular, you'll need more destroyer interfaces, and you'll need more participant. You need to extend participant to create bullets and alien ships and whatever you want to add. Yeah?
So, I mean, I think this question's already been asked a few lectures ago, but like, are there any good indicators as to whether or not to use inheritance versus an interface or an abstract class?
Okay, so you're asking good indicators whether you use an abstract class or an interface?
Or inheritance.
Well,
just regular inheritance.
Okay. So why didn't I make participant an interface? Why did I make participant a class? Yeah? Right, I wanted to implement some of the methods. So I didn't just want to say a participant, if I had said a participant provides methods that deal with acceleration and rotation and so forth, you'd had a whole lot of work to do in all these classes that implement an interface because you'd have to duplicate my code everywhere. So I designed that as a base class to contain a lot of the functionality that you need for participants. Couldn't have done that with an interface. Okay? Why did I make it an abstract class as opposed to a class? A non-abstract. Why did I make it an abstract class? Yeah.
Because you wanted to force some of the methods to be implemented in the extended class.
Okay. So I wanted to say every participant needs to have a method that deals with collisions. But I can't implement that in the participant class because what happens when there's a collision depends on whether you're a ship or a bullet or an asteroid. So I declared that collided with method as an abstract method so that you were forced to implement it down below. And so that I didn't have to implement it in the participant class because I got no idea what to do. So when you got a method that you want to be there, but you don't have any way to implement it now, you make it abstract and force the extender to implement it. Now, if you do that and you end up with an abstract class in which every method is abstract and there's no instance variables, that should be an interface.
Okay, so the key difference is whether or not you need to implement functionality.
Whether you want to implement some of the methods or not. If you just need to say these methods exist, use an interface. Any other questions? Yeah.
I think it was brought up earlier, but could you go over that Javadoc piece?
Ah, right. That was the first thing I was going to do. Thank you. All right, so here's PS11, Zachary Joseph. So I highlight the project. I go to the project menu. For some reason, it's not in the right-click menu. So under project, it says generate Javadoc. I click Javadoc. Okay, I make sure that that this project is selected. So that's selected. You can right here it says, do you want to see the documentation for private? I say yes. Use a standard doclet. Anyway, I'm just taking all the defaults here. I go next. Various things I can pick. I don't know. I'll just accept them all. Next. Okay, I got to provide something. What did I miss?
I think you unchecked it on the last one. I think it was unchecked all. Everything was unchecked, I think. Yeah.
Well, this is good. There's somewhere where you pick the name of the file. That's what I'm missing here. Oh, destination is right there. So I had to add that before. So in the project, I create a doc folder. So let's just provide that by default because I've done this before. Okay, so then I can do the finish. And for some reason, it's not saving. It keeps asking, should it save this XML, UML file, but it's never saving it. So I don't know if we'll be able to post it or not. So I say OK. I say yes to all. And it generates the Javadoc. It's throwing up a bunch of warnings there because I don't have all the tags I ought to. And when you do that, it has created a doc folder down here. And if you open it up and go to index.html, there you have the, you see the documentation for the class. So this shows the packages, asteroids.destroyers, asteroids.game, asteroids.participants, and sounds. You can go into the game package. It shows all the classes. You can go into the display class. It shows the methods. So you get the API generated that way. Yeah, definitely do that because that gives you an easy way to browse through the documentation. It looks just like the Java library because the Java library's API, the documentation is generated the same way. It's generated off of Javadoc comments that developers put in.
What about that map at the beginning of class? How do you create that?
Okay, what at the beginning?
Yeah.
Like the overview?
No, the map that you were looking at the beginning of class.
Oh, the UML diagram? That's a little harder to generate. I will provide you the what plugin to use. But basically what you have to do to use the plugin is you create a new class project and you drag the classes you want to onto the surface. And it will create the diagram and it'll look like crap. In fact, I'll just show you. I can show you better than I can describe it. So, you want to do that, you install the plugin, and I'll post the link. Okay, we'll go back. Let's say I want to generate a new diagram. So I will go into, right here, I will select that. I will say New. I will say Other. Down here under Object A UML diagram, there's Object A and Class Diagram. And I need to give it a name. I'll call it Foo. And I'll say Finish. And it creates a blank diagram. Now what I'm going to do is I'm going to go select everything in here that's a Java file. I will then drag them all out here. And it creates a diagram for me. That's not so bad. When I did it the first time, just lines were all crossing and everything. So And then there are various options. You can control how much detail is displayed here. If I right click on here and show operations and I say none, it takes out the operations.
You can move those, right? Drag them?
Oh yeah, then you can just drag. You can select one of these lines here and grab hold of it. Got the right dexterity, and then you can sort of drag it around. Yeah?
Did you read that again? Like, I know you go down to do that other separate,
Yeah, the wizard was, so it's new. It's not going to be in your, you're not going to see it till you do the plugin. It's under Object Aid UML Diagram under Other.
So, how do you do the plugin thing?
Well, okay, I'll just tell you. There's install new software, let's manage it. There's Object Aid. Let's edit it. It's www.objectaid.com/update/current. So you would take that, and you would put it right there. And then say add. It's fun to play around with, but it's, you know, some people like it better than others, these diagrams. Any other questions? Okay, have a great Thanksgiving, and see you on Monday.